Hi, now we are going to calculate sample standard deviation. And in order to do that, we have to first calculate the sample variance. I have prepared the formula for calculating sample variance. Basically, it is a squared deviation of each individual data set, data point in the data set from the average of the data set divided by the number of the units in that data set minus 1. In some other textbooks or publication, you might see instead of n minus 1 appearing n. There is a fine difference between those two entries. If you see n, that means that your data set represents your entire population. So it's there is a finite population, so you are measuring the standard deviation of that population, which is, and you are taking the n as an entry. If you have a situation when you take a sample from the larger population, which is the most or more realistic scenario, you have to divide n by n minus 1 if you are calculating sample variance. And this arises from the fact that the sample variance is biased estimator of the population variance. But those details are not important as of now, and we can certainly discuss later on if needed. So we have a sample. Certainly these measurements are taken from the larger population, so n minus 1 is a valid entry for this for calculation of this sample variance. Sample standard deviation is just a square root of the sample variance. So let us do some quick math here. So sample standard deviation will be square root of, let's put the value of the denominator, n minus 1 certainly will be 4. We have first entry 68 thousandths of the inch minus sample average is 68 thousandths of inch, and we take the square of it, certainly that's a 0. Then 69 thousandths of inch, second entry of your data set, square. Then third one 70 thousandths minus 68 thousandths. We take the square. Then 67 thousandths minus 68 thousandths square plus let's do that sign. Then 66 thousandths minus 68 thousandths square. Okay, I did math in advance, so if we are going to calculate, we are going to receive 15 10,000ths of inch with rounding off, of course. So that's the we have estimated the variability of the sample. I will leave calculation for the standard deviation in the ODY for you. The next very important topic I would like to cover, I will do in the introduction now, but leave the calculations for the next video is the correlation between measurements in X direction and Y direction. So by calculating the correlation coefficient, we are going to obtain a knowledge whether these variables are there is a relationship between these variables or there is no relationship. Certainly that is gonna that information is gonna give us an insight whether if we the direction in OD in X direction, the OD is getting smaller, whether we see some change in the OD in Y direction and vice versa. If direction in X direction the OD gets larger, whether we see some change in Y direction. So we are going to cover the correlation in the next video. See you then. Bye.